Friends, we are in our last week of chemistry and we've got 2 modules to go. This one's going to be about balancing chemical equations, and then the very last topic that we're going to cover this semester is on types of reactions. So you can see where all of the content we've been doing in chemistry really just builds on each other. And so for this one, you have to be able to make sure you know how to make your compounds, name the compounds, and then we're going to look at counting up the atoms on each side, just what you've been practicing counting atoms, and you understand the concept from the law of conservation of mass. Okay, so balancing chemical equations, we're going to cover this page, and we're going to cover the next page in the handout that has a whole bunch of practice questions. Okay, and also note that this is section number 6.4 in your Nelson textbook. Okay. All right, here we go. This is actually quite fun. Students generally like balancing equations, and if you can count atoms, then you can certainly count and be able to balance a chemical equation, so you might find it fairly easy as well. It's quite fun. So chemical reactions, we remember, obey the law of conservation of mass. You have to have the same number and type of atom on the reactant side and the product side, because the overall mass of the reactants in a chemical equation equal the overall mass of the products. Okay, you can't just create matter or destroy matter. You can't just lose an atom anywhere. They all have to be accounted for. So this is a way to be able to increase the number of atoms. You just can't change the formulas of the compounds. So instead of, changing what a water molecule actually is, all you do is add another water molecule if you need to. So you have to sort of count the atoms as well as counting the number of compounds. And that's where you have to remember from your counting molecule lesson last week, where you need to be able to identify that this is an atom and this is a molecule. So the number of atoms in a molecule are represented by the subscripts, but the number of molecules is represented by a coefficient that goes in front of the molecules to tell you how many molecules or how many particles you actually are dealing with. Okay, so therefore the total mass of the reactants equals the total mass of the products. The number and type of atom that you've got in the reactants equals the total number and type of atom in the products. Okay, and we remember that the number of atoms is really an indirect measure of the mass of something, because an atom of oxygen has a very different mass than an atom of hydrogen. Okay, so how many of these you have is going to be a reflection of the mass. Just as if you've got a molecule of methane, for example, where you've got 1 carbon and 4 hydrogens, the mass that you have is directly related to the number of atoms that you have, the number of atoms and the kind of atom or the type of atom that you've got. Okay, so here are the rules for how you are going to actually balance a chemical equation. And I think when we did our reaction before in the previous module, here was an example of a balanced chemical equation where we had methane and oxygen reacting to give us water and carbon dioxide. How many molecules of each? Well, 1 molecule of methane, 2 molecules of oxygen, 2 molecules of water, and 1 molecule of carbon dioxide. So today's lesson is just about how do you figure out which coefficient you put in front of the molecules, and how do you count them on each side to balance. Okay? Rule number 1. You write out the word equation, right? All chemical equations have can be translated into the word. So that's your name of the compound. Then you're going to write what we call a skeleton equation. And this is where you have to be able to take the word, this is our nomenclature, the name of the compound, and write the correct formula. Okay? So here's why you have to be able to understand that water is H2O. and not the other way around. And that means 2 hydrogens and 1 oxygen, okay? If it's something more complex, like copper 2 sulfate, you have to have the right polyatomic with the right copper and the right number of atoms within that compound. So step number 2 can often be the trickiest. That's where you need to do the most practice because you have to write the right formula down. Then step number 3 is to write what we call the balanced chemical equation, and all you do is you add a coefficient to the beginning of the compound so that the number of atoms on the reactant side are equal to the number of atoms in total on the product side. Okay? Here we go. Some rules. So you could write down the rules if you'd like. Write them on a summary sheet if you don't have a handout because you can't print. That's totally okay. You have to remember that you are never allowed to change the subscripts within a chemical formula. Once you have written the correct formula, that's it. Okay? If I need more carbon dioxides, I can't just start writing C2O4. I can't do that. I have to make sure that I keep my formula the same. And the way that I can reflect having more of these, do I have another one? I do, is to simply put a coefficient in front of it, right? So that would be 2 CO2s. But you can never change the subscript within a formula because that is what it is. What are you going to do? You're going to start by balancing the atoms that occur only once because that's easy. Okay, if you have oxygen on one side and oxygen on the other side, start with those. If you have a metal, oftentimes that's where you're going to start because it's pretty easy. If you've got copper on one side and copper on the other, you're going to balance using those ones first because they're only in one spot. You got to start somewhere. Then you're going to leave any substance that's completely just on its own. You could leave that one to the end. Okay, oftentimes you do everything except for the hydrogen and the oxygen gas or the water because those are the ones that are often on the reactant side and the product side. Those are the ones that you're going to see and they can often be the trickiest. So maybe do everything else first, then leave it to those. The other thing you have to remember is you need to keep checking because once you start adding coefficients to one side, that may change the balancing that you already had. So then you got to go back and check on that side. By adding 2 more of these, well, how did that change the number of atoms? So it's a bit of a balance back and forth until you're finally at that stage where you've got the right number on each side. The video I've shown down here below is an excellent tutorial to help you learn about balancing again. And so Tyler does a great job of explaining that. So I'm going to post those videos. Please make sure you watch those as well. Okay, I'm going to try to go through this fairly quickly. Here we go. Let's practice. And I've got my molecules ready to go here. I've got some hydrogen gas. That's our H2. And I've got some oxygen gas. So I've built these molecules to get us started. Those, remember, are the reactants. What do you think these molecules make? Well, if you have a little engine, right, a hydrogen engine, you can actually make water. How do you do that? Hydrogen and oxygen in a chemical reaction can make water. Now, I've written out my balanced chemical equation. I've written out my skeleton equation right now. And then you can see that I have these on the reactant side and this on the product side. All of a sudden, I see the right number of hydrogen, but I don't have the right number of oxygen. I've got 1 over here and 2 over here. So how do I do that? Well, that's where I'm going to start my balancing. Okay, I'm going to start that and I'm going to take my coefficient and I'm going to start and put a 2 over here. That means that I have now created 2 water molecules based on the fact that I had 1 oxygen, and those oxygen molecules are the atoms and have to stick together. So now I've balanced the correct number of oxygens. Can you see that? Because I've got 2 over here in total, and I've got 2 here. So now by adding a 2 in front on the water side, that's perfect, right? I'm good for balancing my oxygens, but now I've thrown off my number of hydrogens, okay? How many hydrogen atoms do I have in total on my product side? 1, 2, 3, 4, and I only have 2 on my reactant side. So how can I get 4 hydrogens on this side? I need to add another hydrogen molecule, okay? So if I put a 2 in front here, now my hydrogens balance each other out. I have the same number and type of atom on each side of my balanced chemical equation, okay? That is now a balanced chemical equation. Let's do the next one, okay? It steps out all of the steps for you. Step number 1, you've been given a word equation. Gold plus oxygen gives me gold 3 oxide. Now, let's write my skeleton equation, okay? So here's where you have to make sure you've got the correct formula for everything. Gold, how do you represent gold? Simply AU. Oxygen, I have to remember that oxygen is one of my diatomic molecules. So every time you see oxygen, it is always O2. Now I'm going to write my gold 3 oxide. Remember, we've done our practicing with nomenclature. Maybe we did a quiz and maybe you did well on the quiz. So now you can name these. If you can't remember your naming rules, go back to your notes. This is an ionic particle. You take the left and the right and put them together and add an IDE. Right? Let's do the crisscross version. I know that gold is going to have a 3+ charge. Oxygen has a 2- charge. Bring the 3 down, bring the 2 down. I'm going to do the cheater version because I know what that looks like with the Bohr-Rutherford diagram. I know how that works all out where I've got the charges of each and I need to balance the charges. The way to balance a charge is to add a coefficient for the right ratio of ions that are in this particle. And this tells me AuO, I would have 2 atoms of oxygen, 2 atoms of gold and 3 atoms of oxygen to make my correct formula. That's my skeleton equation. Now I look at how many atoms I have on one side and the other side, and now I'm going to do my balanced chemical equation. Do as much rough work as you need. For the first one, you might need a bit more rough work than once you get good at this, okay? I have on this side, in total, 1 atom of Au, and I have in total 2 atoms of O. On the product side, I have 2 atoms of Au, and I have 3 atoms of O. Now, here's where you've got an odd number and an even number. The easiest way to get rid of an odd on one side and an even on the other side is to say, okay, here's where I'm going to write my skeleton equation down below again, and I'm going to add a coefficient as needed. Okay, I'll do this in a different color. I'm going to then put a 3 in front of my O and a 2 in front of my Au2O3. Okay, I'm going to balance out by only using the coefficients because, again, you can't change the formula. Once you've written your formula, that is what it is. The only way to get a number of atoms is to add total number of molecules. To get rid of an odd and even, how do I do that? I multiply the even by an odd coefficient, and I take the even and multiply it by a odd coefficient. Okay, so can you see that? Now how many do I have? And I'm going to use my running tally now. I'm going to go back and I say now I have how many atoms of oxygen on my reactant side? 6. 3 times 2 is equal to 6. How many oxygen atoms do I have on my product side? 3 times 2 is equal to 6. My oxygen atoms now balance. Now I'm going to leave it to the very end where I can put anything, any odd or even number in front of my gold in order to balance that out. And so how many gold atoms do I now have on my product side? I now created 4. And so I'm going to multiply this gold by adding a coefficient of 4 and then double check. 4 atoms of gold on one side, 4 atoms of gold on the other side. 6 atoms of oxygen on one side, 6 atoms in total on the other side. And that is a balanced chemical equation. Okay? Go ahead and try the next one. Aluminum and hydrogen sulfate produces aluminum sulfate and hydrogen gas. Pause the video, do your skeleton equation, and then let's balance and then check. Okay? Here I go. Aluminum. Hydrogen sulfate, H2SO4. Aluminum sulfate, Al2SO43. Hydrogen, H2. This is a good and tricky one, right? If you can't balance or if you can't write your formulas, go back and do some more practice on your nomenclature. Now that I've got this, I'm going to leave my aluminum to the end. I'm going to leave the aluminum to the end because I've only got one on the reactant side, and I've got whatever is going to happen on the product side. I'm going to leave my hydrogens to the end as well because hopefully I can put whatever coefficient I need in front of my hydrogen gas on the product side. Now, here's a trick. If you have a polyatomic that is the same on the left and the same on the right, I can just keep it the same and consider that 1 sulfate on one side and 3 sulfates on the other. Do you see how I did that? That's a cheater version. It's like, why not just group them together because they're are together, so whatever multiplier I use in front is going to balance out in the end. How many sulfates do I have on that product side? Can you see I've got 3 sulfates on the product side? How do I get 3 sulfates on the reactant side? I'm going to put a 3 in front here, okay? Let me go back and just write out my equation again so that you can see that I am just going to write my coefficients in front down below. And remember, you may have to go back and check or change some of those numbers. You can do that. If you need to write out all the number of atoms on each side and cancel and go back and forth, the textbook shows you a great way to do that. Again, do as much or as little rough work as you need. Pretty soon you'll get to the point where you can do that counting in your head and keep track of it, and then just double check your answer. You always know if you've got the right answer because there is only one correct answer when you're doing the balancing, and you can check your own solutions. Okay? All right, so now I've taken care of the sulfate. I'm just going to kind of remember that I've done that. Now what I've done is I've now added more hydrogen atoms on the reactant side. How many do I have? I've got 3 times 2 equals 6. How do I get 6 on the product side? I simply need to add a coefficient of 3. That gives me 6 atoms of hydrogen. So I've balanced my atoms of hydrogen. That's done. I balanced my sulfates. That's done. What's left? My aluminum. How many aluminum do I have on the reactant and product side? That's really easy to see. I've got 2 on the product side. The only way to get 2 on the reactant side is to put a 2 in front as a coefficient. Okay, now I double check. Do I have the same number of reactants and products? Check, 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 check. I'm done, and now I've got my balanced chemical equation. Okay, what are you going to do? You're going to do these ones down here. I'll do some of these with you. Then you're going to work on all of these ones here. And then once you've done some of the textbook questions, I'm going to leave this balancing sheet here for you to work on. Ignore the type of reaction header and column because that's next module, and you're going to go back and look at the type of reaction that you've got based on your balanced chemical equation. So basically it's putting everything together and moving into the last module. Okay, let's do a few more together with you and I'll work you through the steps. Here we go. Aluminum bromide and calcium gives me aluminum and calcium bromide. I've already taken the word equation and just given you the skeleton equation. Let's balance that. Where am I going to start? I'm going to start with my bromine. My bromine, because I've got an odd number on one side and an even number on the other side. And then I'm going to have calcium and aluminum left over, and I can balance those with an even or an odd number no matter what I need. So here's the trick. Odd on one side, even on the other. Let's start with the 2 in front of my aluminum bromide, and let's multiply this by 3. Now I've got 6 atoms of bromine on the reactant side and 6 atoms of bromine on the product side. By adding a 3 in front of the calcium bromide, I've got 3 atoms of calcium on the product side, so let's put a 3 in front of my calcium on the reactant side. How many aluminums? I've got 2 on the reactant side, and so in order to show 2 on the product side, I can put a coefficient of 2. 2, 3, 2, 3. Is the ratio that shows the same number and type of atom on the reactant and product side, follows the law of conservation of mass. Let's do the next one. The next one, I'm going to look at the fact that I've got aluminum oxide on the product side with an odd and an even number all ready to go. I need to get an even number of oxygens so that I can put on the reactant side a coefficient in front of there. So I'm going to start, and I'm just going to pop a 2 over here. Why? Because it's a small number. You want the lowest ratio of those whole numbers, and that's the smallest number I can put in front of aluminum oxide to give me an even number of atoms of oxygen. So I've got 6 atoms of oxygen on the product side. How do you get 6 on the reactant side? Add a 3 in front. Now my oxygens are balanced, and my aluminum, it's pretty easy because I've got 4 on the product side, and I'm going to put a 4 in front of my aluminum. Back and forth, kind of fun. Yeah, let's do the next one. Magnesium chloride and sulfuric acid, probably. And then I've got aluminum sulfate and, magnesium sulfate and hydrochloric acid. Okay, let's have a look. I've got some sulfates there. I'm going to have 1 on each side. They're not going to change, but I'm going to consider them grouped together. Okay, I have 1 on each. Okay, perfect. That's already balanced. My magnesium is already balanced. What's not balanced? My chlorine. Magnesium chloride has 2 atoms of oxygen, or 2 atoms of chlorine on this side. I'm going to put a 2 in front of my HCl over here, and that creates 2 hydrogens, and now my hydrogens are balanced. Are we done? Yep, we're done. Let's do the last one. Gold bromide, gold 3 bromide, and it gives me gold and bromine. So you can see I've got my 2 bromine on my product side. So let's use that rule of odd and even again. I'm going to pop a 2 in front of here. My bromines are now going to be balanced if I put a 3 in front of here, and I've left the gold until the end. I've got 2 on the reactant side and 2 on the product side. Okay, give it a go. Practice, practice, practice. Use a pencil for sure for this, and don't forget to watch the other videos. And that's it for balancing chemical equations. Good job, everybody.